Climate change, as revealed by gradual changes in temperature, precipitation, atmospheric moisture, wind intensity, sea level rise, but also changes in the occurrence of extreme events, is already affecting our cultural heritage sites. Hyperion is an ambitious project that aims to support cultural heritage resilience against climate change. Coordinated by the iSense group of the Institute of Communication and Computer Systems in Greece, the project unites 18 partners from 8 European countries. Currently, the project consortium performs extensive tests in the historical areas of 4 different demo sites: in Greece, in the island of Rhodos, in Italy, Venice, in Spain, Granada, and in Norway, Tonsberg. Let us now introduce you to Hyperion's 4 demo sites.
We are currently in the first demo site of Hyperion with 4 monuments on the island of Rhodes in Greece, which is situated in the South Aegean Sea, one of the highest seismic risk areas of Greece. Through its long history, the city of Rhodes, which is located at the northern tip of this island, has not only been vulnerable to severe earthquakes, but also to hazardous weather conditions and erosion. The local climate of high participation and extreme heat has also been gradually intensified by fires and air pollution due to the increase in population in the city center. We are monitoring and gathering data on the monuments of the St. Nicola Fortress where we are now, the Nayak Tower, Rodini Grave Complex, and the Roman Bridge, to assist in their protection and timely conservation.
The clock tower in St. Mark's Square, one of the most famous monuments, has been chosen for the demonstration activity of Hyperion.
The location of the clock tower is therefore ideal for evaluating the effects of the environmental forcings on the deterioration of its building materials.
Petrographic, physical and chemical properties of the building materials have been fully characterized, and a network of sensors have been installed inside the building. We are presently at the clock tower in Venice and outside the building on the different walls. These data feed a model developed by Oslo Met University describing the behavior of the building under microclimate conditions.
We are currently at the demo site of Hyperion in Granada, the monastery of San Jerónimo. Due to the type of rocks nearby Granada, landslides are always a problem that is also affected by climate change. This is already present at La Sabica Hill, where the Alhambra is located. It is reported that the north side of La Sabica, at the pit of San Pedro, has a rate of movement of few millimeters per year. Extreme heat is also a problem. Lately, there is an increment in the maximum summer temperatures that may affect many of the vulnerable construction materials and soils. Granada experienced temperatures below zero in winter and above 40 degrees in summer, having frequently freeze-thaw cycle, which is expected to increase in the future.
Valuable historic buildings and ruins in the area are made of local stones and wood. The concern is, how are these materials affected by a changing climate with decreased events of extreme weather? A warmer and wetter climate also leads to increased biological growth. This is very harmful for buildings made of wood and timber like the Heierstad loft, where degradation and rot accelerate. Freeze and thaw cycles are affecting the masonry and stone structure at the Slottsfjellet, leading to degradation and erosion of their original structures and surfaces.
Hyperion is also taking into account the local ecosystems in the cultural heritage areas and has developed a communities engagement ICT tool in which citizens can create stories and share photos on the deterioration of cultural heritage monuments. To support our vision, download Hyperion's app and make your contribution in the preservation of the European cultural heritage. Cultural heritage is not something of the past, but it is a foundation that fosters our route to the future. Let's save it all together. Thank you.